JEE Mains PYQs on some basic concepts of chemistry. See the first question. Which one of the following constitute a group of isoelectronic species? Isoelectronic meaning here same number of electrons. Same number of electrons. Like first example, if you see how many electrons in C2 2 minus, how we calculate? Atomic number is equal to number of electrons. If there is minus 2 means gain of 2, plus 2 means loss of 2. C2 minus 2 I am showing like this, 2 into 6 plus 2, which is equal to 14 electrons. Why plus 2 here? Because 2 electrons gain. And similarly, O2 minus 2, 2 into 8, 2 into 8 plus 2 plus 1 because only 1 electron. So here it is 15 electrons. So if you do for even others, here you will get atomic number 6 plus 8, 14 electrons. And then 7 plus 8, 15 electrons. So these are not isoelectronic species because 14, 15, 14 different electrons. And you see second option, nitrogen 7 atomic number, oxygen 8. So plus meaning here loss of 1 electron, 14 electron. Here also 14 electron. Cn 6 plus 7 plus 1. So 14 electrons. Minus means gain of electrons. Here 14 electrons. So all are having same number of electrons, isoelectronic. Same if you do for third and fourth, you will get answers here. Matching correct answer is second option. Same number of electrons should be here. Next, moving further. Ratio of number of oxygen atoms, 16 grams of ozone, 28 grams of carbon monoxide, 16 grams of oxygen. So how we need to see here. Number of oxygen atoms. First I am taking here number of oxygen atoms in O3. Number of oxygen atoms in O3 if I take, how many you are getting? See here. Number of oxygen atoms in O3 is equal to, which formula we use? W by M is equal to N by Na. W is given weight, M is molecular mass of O3, ozone, N is equal to number of ozone molecules and Na. So finally here, number of O3 molecules is equal to Na by 3, because 16 by 48, 1 by 3. But here what we need? Number of oxygen atoms. Number of oxygen atoms is equal to Na by 3. Each ozone having 3 oxygen atoms. Overall here answer should be Na. Answer is Na. Similarly, if I do for second option, means second compound, 28 grams of carbon monoxide. Directly I am doing now. Number of oxygen atoms in CO is equal to, W is 28, M is 12 plus 16, 28, N by Na. So here N is equal to number of oxygen atoms is equal to Na you will get. So here also Na, here also Na. Similarly, you do for third option. Third option also you will get here Na similarly. Hence answer should be, what should be the answer here? Answer should be 4. So here N gives, in first case N gives number of O3 molecules. Here N means number of CO molecules. Next, that is O2, N means number of O2 molecules. Then you have to multiply with 2 to get number of oxygen atoms. Next PYQ, the density of 3 molar solution of sodium chloride is 1.252 gram per ml. The molarity of this solution will be. So here we know, here we already know molality is equal to, number of moles of solute by weight of solvent. Weight of solvent in kg. So now by using this weight of solvent in kg, we can proceed further for the calculation. But here first we need to calculate number of moles of solute. First we need Even weight of solute, weight of solvent, both we need. So how to find? See here. Here we know. Then how we can find? Number of moles of solute is equal to here there is one direct formula also here. We studied first the direct formula. Anyway you can do. So molality is equal to 1000 into molarity by 1000 into density of solution, direct from interconversion formula it is, minus molarity into molecular weight of solute, direct interconversion formula. So what you will get here? 1000 into density of solution, how much? 1.252 by 1000 into density of solution. Sorry, here molarity is 3 molar, density of solution 1.252 minus molarity 3 into molecular weight of solute, NaC here it is 58.5. Direct interconversion formula it is. So after overall calculation, here you will get 2.79 small m. That is molality. So 2.79, which is fourth option. Observe this once overall here interconversion formula. Next, moving further, amount of oxygen in 3.6 moles of O2. Amount of oxygen in 3.6 moles of O2. See now. So how we need to calculate here? So it's simple it is. Amount of oxygen 3.6 moles of O2. We know number of moles is equal to weight by molecular weight. 3.6 given, W you have to find, sorry, H2O, water it is. Water how much? Molecular weight is 16 plus 2. Amount of oxygen in 3.6 moles of H2O they are asking. Okay, first let us see here weight of H2O, then we'll just a minute, other directly we'll do. They are not asking about H2O. So first you see here weight of oxygen in H2O. Weight of oxygen in H2O is equal to how much? 16 grams because oxygen is 16. Weight of oxygen in H2O. Which one? If I take here it as 1 mole of H2O. But if I take here weight of oxygen in 3.6 moles of H2O, 3.6 moles of H2O, so what we do? 3.6 into 16, which is equal to 57.6. 57.6. So answer should be fourth option, that is amount of oxygen in 3.6 moles of water, that is 57.6 here. Next question. 5 liters of an alkane requires 25 liters of oxygen for its complete combustion. If all volumes are measured at constant temperature and pressure, the alkane is. See, first of all, alkane general formula you see. General formula of alkane is CnH2n plus 2. If I balance the reaction by using general formula itself, which is giving NCO2 plus N plus 1 H2O. General formula of alkane. General formula of alkane here, what we used means combustion, balanced reaction. What is N here? N is number of carbon atoms. So here we know 5 liters of alkane, 25 liters of oxygen. Meaning here for 1 liter of alkane, we need 3n plus 1 by 2 liters of O2 required for 1 liter of, that's what a kind of balanced chemical reaction we can interpret. Then if it is for 25 liters, 5 liters of alkane. 1 liter 3n plus 1 by 2. Here what we need. So now we need to consider for how much we need. 1 liter 3n plus 1 by 2 liters. Then 5 liters how much we need here, that we need to first clearly observe it overall. So they mention here 5 liters of alkane requires 25 liters of oxygen for its complete combustion. Okay. So now how we need to proceed? Once think everyone. Instead of going directly for solution, CnH2n plus 2, 3n plus 1 by 2 O2, NCO2 plus n plus 1 H2O. 1 liter of alkane giving 3n plus 1 by 2 liters of O2 required. Because it is balanced chemical reaction. So 5 is giving 25 liter, or you can say here 1 liter of alkane. If I take 3n plus 1 by 2. See, 5 liter require 25, 1 liter of alkane require 3n plus 2, 3n plus 1 by 2. So here they mention here 5 liters required, 25 liters, then 1 liter required, 3n plus 1 by 2 liter. So here it is equal to 3n plus 1 by 2 required is equal to 5, where n is equal to 3. If n is equal to 3, then which should be? It should be propane. Direct question. There is one balanced reaction for alkanes. According to given equation, see here, 1 liter is equal to 3n plus 1 by 2 liters of O2. So 5 liters is equal to 25 liters they mention. 5 liters of 1 liter, how much we need? 1 liter required 5 liters of oxygen. Okay, 3n plus 1 by 2 is equal to here 5 liters. That's why we got propane. Next, group having isoelectronic species. See here, group having isoelectronic species. We know isoelectronic meaning. Isoelectronic meaning same number of electrons. Same number of electrons. So the group where you can see same number of electrons. Second option you see. Second option, because same above already we discussed. Atomic number 8 minus 2 means 10 electrons. 9 plus 1 10 electrons. Sodium 11 minus 1 10 electrons. Magnesium 12 minus 2 10 electrons. So isoelectronic species, that is option 2. Next, a solution of sodium sulfate contains 92 grams of Na plus ions per kilogram of water. The molarity of Na plus ions in that solution in mole per kg is. Okay. The molarity of Na plus ions in that solution in mole per kg is molarity of Na plus ions. First of all, we should know in 92 grams of Na plus they mention. So number of moles of Na plus first you have to calculate, which is 92 by sodium molecular mass 23. So 4 moles of Na plus present. So here molality is equal to number of moles of solute by weight of solvent in kg. Per kg of water they mentioned, right? So here per kg if we take, so answer is 4 mole. Direct question. How easy question it is, see. 4 molar, answer is option 3. Next, the amount of sugar required to prepare 2 liters of its 0.1 molar aqueous solution is. Amount of sugar required to prepare. So here amount we have to calculate here. So first we take molarity is equal to number of moles of solute by volume of solution in liters. So number of molarity is given. Number of moles, weight, how we calculate? Weight by molecular weight of sucrose, which is 342. They give atomic masses by volume of solution 2 liters. So weight is equal to 68.4 grams. 68.4 grams, that is option 1. Direct question. Next, 8 grams of NaOH. 8 grams of NaOH dissolved in 18 grams of H2O. Mole fraction of NaOH in solution, molality of the solution respectively are 8 grams of NaOH dissolved in 18 grams of H2O. So we have to calculate molality as well as mole fraction of NaOH. Okay, first you calculate number of moles of NaOH, because mole fraction we need moles of each component. 8 by NaOH molar mass 40, 0.2 moles. Then number of moles of H2O. Number of moles of H2O is equal to 18 by 18, which is 1 mole. 18 by 18 is equal to 1 mole. Okay. So now based on this information, mole fraction of NaOH is equal to moles of NaOH by total moles, 0.2 plus 1. So which is 0.167. Two options with 0.167. So mole fraction here it is 0.167 presently. And we need to calculate even molality. Once if you know this, molality easy to find. Molality is equal to how many moles? Number of moles of solid 0.2 by 18 grams of H2, weight of solvent, so 18 grams. You have to convert into kg. I am using 1000 here, so 11.1111 molal. In grams, but we need in kg, right? So just I convert it into kg, 11.11 molal. So overall, the answer should be here. Answer for the given question, which is correct answer. So it should be option 1. Option 1 is correct. Next question. The limiting reagent question, most repeatedly asked question format it is. So identify dihydrogen as a limiting reagent in the following reaction mixtures, where dihydrogen acting as limiting reagent. So how to find limiting reagent? Here we know trick to find limiting reagent. You take here given moles by stoichiometric coefficient. Whichever is having smaller value, that is LR, limiting reagent. Whichever is having smaller value, that is LR. First option you see here. First of all, how many moles of nitrogen present here? First you calculate number of moles for this. Number of moles, how many? Number of moles of N2 is equal to 14 by N2 28. Number of moles of hydrogen, which is 4 by 2, which is 2. So these are given moles. So how to find limiting reagent? Limiting reagent is here given moles. Whatever given moles we got here in the given question, first we calculate moles. How many moles? 14 grams of N2 means 28 it is. So 0.5 by stoichiometric coefficient here 1, 2 by stoichiometric coefficient 3. So here it is 0.5, here it is 2 by 3, it is 0.66. Here which is limiting reagent? The one with smaller value is limiting reagent. So here LR is nitrogen, but they are asking dihydrogen as limiting reagent. See what we did here. Given moles by stoichiometric coefficient, here we applied the given ratio. Wherever we are getting lowest value, that is limiting reagent. So like that every option you need to solve. And then moving further, I am taking here third option. Similar pattern here. No complexity. So now if you do for same in this case, first you find number of moles of N2. How? 56 by 28, so which is 2 moles. Number of moles of H2, 10 grams by 2, which is 5 moles. Now find LR. Use this simple trick. How to find? In finding LR, given moles by stoichiometric coefficient. So 2 by stoichiometric coefficient of nitrogen 1, and here 5 by stoichiometric coefficient of hydrogen, it is 3. So we are getting here 2 here, and see next That is 5 by 3 here we got. So which is 1.66. See now, lower value here we got. So that's why here it is limiting reagent. In third option, hydrogen is limiting reagent. See the format. We calculated number of moles of each and the number of moles by stoichiometric coefficient. Stoichiometric coefficient meaning the numbers before the reactants and products. So answer should be 3. So after taking this ratio, whichever is having smaller value, that is limiting reagent. Next, the average molar mass of chlorine 35.5 gram per mole. The ratio of 35 Cl35 to Cl37. They are asking about ratio of Cl35 to Cl37. See, similar pattern question number of times repeated. Observe it. Average molar mass. So they gave average molar mass is 35.5. Here we know one formula. The formula for average molar mass. See here, average molar mass. So average molar mass is equal to percentage abundance of isotope 2, percentage of isotope 1 into its atomic weight, percentage abundance of isotope 2 into its atomic weight by total abundance in atmosphere. Total abundance in atmosphere. Okay. So now we have to consider here average molar mass. It is given as 35.5. Percentage of 1 into atomic weight. Percentage of 1 we don't know here. So I am taking it as x. If I take it as x into atomic weight 35, which one? Isotope 1 plus another one 100 minus x, atomic weight 37 by total abundance 100 anyway. Total abundance 100. So if you do here, then here x is equal to, you will get 75 percentage, and 100 minus x is equal to 25 percentage. So it is 35 Cl35 isotope. Here it is Cl37. Cl37, Cl35. Ratio, if you observe it, observe the ratio here. What is the ratio? 75, 25, which is 4 is to 1. Sorry, 3 is to 1. 3 is to 1. So answer should be 3 is to 1 here. That formula we applied. That percentage abundance means availability in atmosphere of Cl35 is x, other should be 100 minus x. Total abundance anyway 100 percentage. Next question. Complete combustion of 1.80 grams of an oxygen containing compound CxHyOZ gave 2.64 grams of CO2, 1.08 grams of H2. Percentage of oxygen in the organic compound is. Okay. So first I am taking here number of moles of carbon. Here we know number of moles of carbon is equal to number of moles of carbon dioxide, because 1 mole of carbon present in 1 mole of CO2. Number of moles of CO2 we calculated 0.06. Similarly, number of moles of hydrogen is equal to 2 into number of moles of H2O. Number of moles of hydrogen is equal to 2 into, because each H2O contains 2 hydrogen moles. That's why we did here. 1.08 by 18 into 2, which is equal to 0.12. So next to see here 2.64 grams CO2, 1.08 grams of H2O. The percentage of oxygen in the organic compound is. Percentage of oxygen we need to find. So now what we need to find in this case? Number of moles of oxygen or you can say mass. mass of oxygen, and see information what they gave here. How we got 1.80 and 0.72? Because they mentioned complete combustion of 1.84 grams of an oxygen containing CX gives 2.64 grams of CO2, 1.08 grams of H2O. So here if we do, so observe it everyone. Okay, here we got number of moles of hydrogen. Now to get weight of oxygen, what we do here? Weight of oxygen is equal to total weight of compound minus weight of carbon plus weight of hydrogen. Total weight of compound how much? 1.80 minus weight of carbon. How you will get? How many moles we have? 0.06 moles. 0.06 moles into its atomic weight is 12 plus weight of hydrogen. How you will get? 0.12, its molecular weight is 2. Overall if you do here, 0.96 grams left over, that is oxygen. Then percentage of oxygen is equal to 0.96 by total weight 1.80 into 100, which will give 53.33 percentage. 53.33 percentage, that is option 3. First we calculate number of moles of carbon, then followed by hydrogen. Then weight of oxygen, how we calculate? Total weight minus sum of carbon hydrogen weight. We got 53.33. Next, NaNO3 weighed out to make 50 ml of aqueous solution of 70 milligrams Na plus per ml is dash. See the question. Observe everyone, first question. Before going further, see question we need to read properly. If you read question properly, then you will get more clarity about how to frame. Observe it question. Here NaNO3 weighed out to make 50 ml. First you calculate here Na plus present in 50 ml. Like NaNO3 is equal to Na plus. So Na plus present in 50 ml. Na plus present in 50 ml is equal to 70 milligrams by 1 ml into 50 ml is equal to 3500 milligrams. 50 ml of an aqueous solution containing 70 milligrams Na plus per ml is, per ml they are asking. So per ml if you calculate 3500 milligrams, or which is equal to 3.5 grams. So now number of moles of Na plus is equal to 3.5 by 23, which is equal to number of moles of NaNO3. Why? Because each NaNO3 contains one Na plus. Number of moles of NaNO3 here we can make it equal. So weight of NaNO3 is equal to 3.5 by moles into its molecular weight. Molecular weight of NaNO3 is 85. So 993 grams you will get in this case. So answer here it is. So what they are asking, round it up to the nearest integer in the question if you see. So you can do it as 13. Answer is 13 grams. Answer. Okay. Next question. Complete combustion of 750 grams of an organic compound provides 420 grams of CO2, 210 grams of H2O. The percentage composition of carbon, hydrogen, organic compound is 15.3 respectively. Again, round it off to nearest integer. See the question. Similar pattern question here. So how we need to find? See here. 44 grams of CO2 contains 12 grams of carbon. Okay. Then 420 grams of CO2 contains how much? 12 by 44 grams having 12 grams of carbon, 420 grams of CO2 contains how much? 12 by 44 into 420, which is equal to 1260 by 11 grams of carbon. This much amount of carbon present with us. Okay. Or if you further do it calculation, 114.545 grams of carbon present. That is the amount of carbon. So now percentage of carbon, how we find? Given mass of carbon 114.545 grams by 750 grams into 100, which is equal to 15.3 percentage. The percentage of carbon 15.3. So here they are asking percentage composition of carbon, hydrogen and organic compound is 15.3 and dash respectively. Carbon we got 15.3. But now what we need here? Percentage of another one, that is hydrogen. So here how we find? 18 grams. Here I am showing separately. 18 grams H2O contains 2 grams H2. Then 210 grams of H2O contains 2 by 18 into 210, which is 23.33 grams H2. So now percentage of H2 is equal to, how we can do? The mass of hydrogen by total mass of compound into 100. Total mass of compound into 100, which is equal to how much? 3.11%. So here it is, answer is round off to nearest integer. So you can take it as 3%. So answer here it is 3. Answer is 3. Next question. The mole fraction of urea in aqueous urea solution containing 900 grams of water is 0.05. If the density of the solution is 1.2 gram per centimeter, cubic centimeter, the molarity of urea solution is. Molarity of urea solution is. See. Observe the next question, everyone. It is based on mole fraction related question. See now, mole fraction of urea in an aqueous solution, urea solution containing 900 grams of water is 0.05. If density of the solution is 1.2 gram per cubic centimeter, the molarity of urea solution is. So here how we need to calculate? See, 1.2 grams density of solution given. Okay. Okay, mole fraction of urea here is equal to 0.05, or how we write? Number of moles by number of moles plus 50. Why we are writing 50 here? Number of moles of urea 0.05 mole fraction of urea, that is 0. If the density of solution is molarity of urea solution, molar mass of urea and water already given. So now if I take 19N is equal to 50. 19N is equal to 50. Here N is equal to how much you will get? 2.6315. Number of moles is equal to, see why I wrote here 50? Why I wrote here 50? Number of moles of urea by number of moles of H2O. How many moles of H2O? 900 grams of water by 18, which is equal to 50. That's why I wrote directly here 50. Remember. So N is equal to 22.6315. That is number of moles of urea. So now volume of solution is equal to what we can write now? 2.6315 number of moles of urea plus, means weight of urea plus weight of which one? Water by the density of solution. So we know density is equal to mass by volume. Density is equal to mass by volume. Same formula I am using here, mass by volume. Here volume is equal to mass by density. So now here volume of solution, how much we are getting? Volume of solution 881.5 around approx ml. So now molarity is equal to regular. Now after knowing this value, remaining easily you can do it. Molarity is equal to, now use the formula, direct molarity formula. So what you will get in molarity formula? If you apply number of moles of solute by volume of solution in liters. So here I am showing separately. Molarity is equal to 2.6315 by, it is in ml. So to convert into liters, I am dividing, so it comes to numerators. Overall you will get 2.9, or you can say 2.98 molar. 2.98 molar. So you can, then it did mention about rounded top. So 2.98 range they provide here, 2.98 to 2.99 like that. So answer is 2.98. Next question. An organic compound contains carbon, hydrogen, sulfur. Minimum molecular weight of the compound containing 8% sulfur is. See here, minimum molecular weight based questions these are. So how we calculate minimum molecular weight based questions? Once, see now. So minimum molecular weight based questions, how we do? Simple here. Let molecular weight of the compound, let molecular weight of compound be, think that X, then if minimum one atom present, if minimum one sulfur, so these questions are important. If minimum one sulfur present, so one sulfur minimum meaning how much amount? 32 grams. So percentage of sulfur is equal to weight of sulfur by total mass of compound into 100. Weight of sulfur, percentage given as 8%, weight of sulfur is 32, x into 100. So here x is equal to, in this case x, in the calculation how much you will get? Calculate here. It should be, under x calculation you will get around 400. So answer should be here 2. 400 is answer. Next, amount of arsenic pentasulfide that can be obtained. Arsenic pentasulfide that can be obtained. So here formula important. You should know formula. Balanced reaction also important. See here, H3ASO4 arsenic pentasulfide reacting with H2S and HCl to form arsenic pentasulfide, that is AS2S5. Just I am applying POAC. No need to think about balancing. Amount of arsenic pentasulfide that can be obtained when 35.5 grams of arsenic acid treated to excess H2S, assuming 100% conversion. Okay. So I am applying POAC for arsenic. For arsenic, let us apply it. If I apply for arsenic, so what we are going to get here? So number of moles of AS2S5 into, like product side, how many arsenic atoms? 2 here. Reactant side, number of moles of H3ASO4. How many? Only 1 mole of arsenic, so into 1. So moles of AS2S5 is equal to 35.5 by 142 into 2. Overall here you will get 0.125. Answer is 0.125. See, what is 142? That is molecular weight. Molecular weight. So molecular weight of AS2S5, 142. Here you specify AS2S5 molecular weight is 142. That is given. So once if you know this information, easily you can calculate 142. Okay. Next. So answer, what should be answer here? 0.125. So answer is 3. Next question. 10.30 milligrams of O2 is dissolved into a liter of sea water density 1.03 gram ml. So observe the question now. 10.30 milligrams according to given question. So how we need to calculate O2 in ppm. In parts per million you have to calculate here according to given question. First everyone observe. See now question. Here we know number of ppm is equal to weight of solute, which is 10.3 into milligram, I am converting into grams, by weight of solution. Seawater of density 1.03. Seawater of density 1.03 gram per ml. So here weight of solution you can take, or weight of solute. Anyway, you will get almost same answer. So 1 milligrams of O2 dissolved in seawater of density 1.03 gram per ml. You take here weight of solution milligrams, you will not get much more difference. Weight of solution is equal to what you will get, 1.03 density into volume 1000, so which is 1030 grams. Density given, right? That is. So here what we wrote, here it is density into volume. So directly you can write 1030 into 10 power 6. That is million. So answer is 10. 10 is answer for this question. Next question. The mole fraction of glucose in an aqueous solution is 0.1. The mass percentage of water in it to the nearest integer is. So mole fraction of glucose they mention. Again everyone refer once question. See now how to proceed with this. Let total moles. If total moles is 1 mole, if total moles is equal to 1, then moles of glucose, you can take here moles of glucose. Here moles of glucose will be 0.1, and then moles of water, moles of H2O is equal to 0.9. So then percentage of mass of H2O, easy now. Mass of H2O 0.9 moles, meaning if you multiply with molecular weight you will get here weight of H2O. 0.1 moles of glucose, its molecular weight is 180 plus here 0.9 into 18. 18 is molecular weight of water into 100 if you do, here 47.36%. So nearest integer if you do, you can take here 47. So answer is 47. Next question. Complete combustion of 3 grams of ethane gives x into 10 power 22 molecules of water, the value of x. So here first observe everyone question. Reading question is important instead of going directly. Complete combustion of, so first you refer it. Okay, see now 3 grams of ethane. First of all, what is ethane here? Ethane C2H6 giving molecules of water. Think that here it is giving x into 10 power 3 grams of ethane gives x into 10 molecules of water. The value of x is dash. They are asking about value of x. Okay, if you balance the reaction, complete combustion, balance the reaction, direct I am writing. So C2H6 or if C2H6 gives 3H2 or you show complete reaction also without any doubt. If it is reacting with O2, then it forms CO2 plus H2O. CO2 plus H2O. If you balance the reaction, 2 CO2, 3 H2O, so here 7 by 2 O2 if you take. So according to the given question, here 1 mole of ethane will give 3 moles of water. 3 moles of water. 3 grams of ethane, that is 1 mole of. So what they mentioned here, 3 grams of ethane. Okay, 3 grams of ethane. First to convert into moles. Number of moles of ethane is equal to 3 by, what is molecular weight of ethane? 24 plus 30 it is 0.1 mole. So 0.1 mole of ethane will give 0.3 mole of sorry, 0.3 moles of water. If it is 0.3 moles of water, how many molecules present in it we need to see. So number of molecules in 0.3 moles of H2O. 0.3 moles of H2O. So what we can write here? 0.3 moles meaning here Avogadro's number is equal to 18 into 10 power 22 you will get, because 3 into 6 point Avogadro's number here. So then what we can write here? Exactly if you see 18.069 into 10 power 22. So answer should be here. Nearest integer if we take here 18 into 10 power 22. So the x value whatever they gave in the question is equal to x. Answer is 18 here. You can write here 18. Okay. So that's all about some important repeatedly asked JEE Mains questions format. Many questions we discussed, and repeatedly asked JEE Mains important question formats we discussed. So it is about JEE Mains PYQs based on some basic concepts of chemistry. And next lecture, we are going to discuss PYQs of JEE Advanced. Here we discussed only JEE Mains. Next lecture, PYQs of JEE Advanced based on some basic concepts of chemistry. Don't miss that video. If you have any doubt, once again watch this so that you will get more clarity. Thank you. Thank you for your patient listening.